Hi everyone, it's Miss Costa here, and in this video we're going to be going through the Edexcel Paper 1 for the November 2022 series. Okay, so in this first question I'm being asked to write 500 as a product of powers of its prime factors. So there's a few keywords here. First of all, I'm being asked to write 500 as a product, which means as a multiplication of powers of its prime factors. So it's just helpful to quickly remind ourselves of the prime numbers. They're 2, 3, 5, 7, 11, and so on. So that's what we're going to be looking at. Now, when we do a question like this, we start off with 500 and we do a little factor tree. So we think to ourselves, what are two factors that multiply together to make 500? And ideally, one of them is going to be prime. So the easiest one to start off with is always 2. And 2 times 250 makes 500. Now, when I get to a prime number, I circle it and that branch of the tree is extinguished. And then I just go with anything that's left. So I now have 250 and I want to think to myself, what two numbers multiply together to make 250? Well, I could divide by 2 again. So 2 times by 125. Once again, I circle the 2. And then I look back at the 125. I know that 5 is going to go into it. And 5 times by 25 is going to give me 125. Once again, I look at 25 and I know that that is made by multiplying 5 times 5. So now that I have got to the end of the tree, there's nothing else to find. I can write 500 as a product of its its prime factors. So I'd say 500 equals 2 times 2 times by 5 times by 5 times by 5. You can double check this on a calculator. If you type that into your calculator, you'd end up with 500. But the question is asking me to write it as a product of powers of its prime factors. So I need to then simplify this. So 2 times 2 would simplify to 2 squared, and 5 times 5 times 5 would be 5 cubed. So my final answer is 500 equals 2 squared times by 5 cubed. And in this question, I am being asked to add some mixed numbers. So the really important thing to remember is that when you're adding mixed numbers, you're going to want to turn your fractions into improper fractions first. So 1 3/5, to turn it into an improper fraction, and multiply the denominator by 1, so 5 times 1, and add on 3. So that would become 8/5. And then for 2 1/4, I would multiply 4 times 2, which is 8, add on the 1, so that's 9/4. Okay, so now I've got them both into improper fractions. And what I want to do, in order to add or subtract fractions, this is basic fractions, algebraic fractions, all fractions, in order to add or subtract fractions, they need to have the same denominator. Okay, so the way you find the same denominator is generally by finding the lowest common multiple. So the first number that is in the times tables of both 5 and 4, which is 20. So then you think to yourself, what have I multiplied 5 by to get to 20? I've multiplied it by 4. And to keep the fraction in the same proportion, I'm going to have to multiply the numerator by that as well. So 8 times 4 is 32. I then think about the other side. What have I multiplied 4 by to get to 20? I've times it by 5. So I'm going to have to multiply the numerator by 5 as well. And 9 times 5 is 45. Now that they are both with the same denominator, I can just add them. So 32 plus 45 is going to give me 77 over 20. And the question is asking me to give my answer as a mixed number. So then I think to myself, how many times does 20 go into 77? Well, I know if I write out the 20 times tables, 20, 40, 60, then 80. So that's 3 wholes. And then from 60 to 77, I'm left with 17. So I write that as 3 and 17 over 20. Okay, so this is a show that question, which means you want to show your working and show each step of your reasoning. So let's start off by saying what does this actually mean? Well, 2 2/3 divided by 6. I know I'm working with a fraction, so I'm going to want to turn 6 into a fraction. And how do you do that? Well, to turn any number, so let's just say 52, to turn any number into a fraction, you just write it over 1. If it's an integer, a whole number, you just write it over 1. Okay, so then I've got my fractions. Now, once again, I'm going to want to turn any mixed numbers into an improper fraction. So 2 times 3 is 6, add on the 2 is 8. So that becomes 8/3 divided by 6 over 1. Now, when I'm dividing fractions, you might know the KFC method or the KCF method, whichever way you prefer. So keep the first fraction exactly as it is, change the sign to a multiplication and flip the last fraction. So that would be 1 over 6. And then once you've got that, so this is not like adding and subtracting fractions. We don't care about the denominators. We just multiply the numerators together and multiply the denominators together. So that would become 8 over 18. And now it's asking me to show that it equals 4/9. So all I'm going to do is simplify it. If I do 8 divided by 4, 8 divided by 2, because I'm trying to get 4, that gives me 4. So 18 divided by 2 gives me 9. So I've shown that that fraction would simplify to 4/9, okay? And you need all of this working. The important thing is, obviously you can work this out, but they've given you the answer. So given that they've given you the answer, you want to show every little step of your working. So this is a nice little index laws question. So just as a reminder, the rules of indices, when you are multiplying indices, so when you are multiplying indices, you just multiply the powers. So let's say you had x to the power of m times by x to the power of n. The final result would be x to the power of m plus n. Okay, so when you're multiplying indices, you add the powers. So let's work out what's in the brackets first, because using BIDMAS, you always have to do what's in the brackets. So -5 plus 8, because I know 2 to the power of -5 times 2 to the power of 8 is going to be 2 to the power of -5 plus 8. Okay, so there's my working. -5 plus 8 is 3. So then I've simplified this to 2 cubed to the power of 2. Now, the law of brackets is that when you have anything inside the bracket multiplied by a power outside of the bracket, you multiply the powers together. So that would become 2 to the power of 3 times 2, which gives you 2 to the power of 6. Okay, so when we're multiplying decimals, the best thing to do is to just treat them as whole numbers. So first of all, I could turn that into 4 times 32. I can then multiply it. This is a non-calculator question, so you can either multiply it using whatever multiplication method you like, or you can use the doubling and halving trick. So sometimes that's helpful, sometimes it's not, you decide. So if I doubled one part of this calculation, so if I doubled 62 and made it 64, and I halved another part, I'm going to end up with exactly the same answer. So 2 times 64 is 128. Therefore, 4 times 32 must also be 128. Just to prove it, if I halved this to make it 1 and I doubled that, you see that it always works. Okay, so it's doubling and halving trick works for multiplication. I would really encourage you to familiarize yourself with it if you don't already know it, because it just speeds things up on the non-calculator. So we know that 4 times 32 is 128. And what have I done in order to turn my decimal into integers? I've times 0.04 by 1000, and I've times 0.32 by 100. So therefore, in order to get back to my original, I'm going to need to divide by 1000 and then by 100. Now, the quick way, or the trick way to figure out what you need to do for this, is to look at your calculation and think, how many digits are after the decimal point in my calculation? I've got 1, 2, 3 digits here, 1, 2 here. So in total, I have 5 digits. So 1, 2, 3, 4, 5 digits in my calculation. So therefore your answer is going to be the same digits as 4 times 32, but it's going to need to have 5 places after the decimal. So you start filling your number out from the end. So 128 would be filled in there, and everything else becomes zeros. So in this question, I'm being told that a car factory is going to make 4 different car models, A, B, C, and D. 80 people were asked which of the 4 models they would be most likely to buy, and the table shows their results. I'm then told that the factory is going to make 40,000 cars next year, and I need to work out how many Model B cars the factory should make. Well, I know that out of 80 people, 15 out of 80 said that they would choose Model B. So the relative frequency, the probability of someone wanting a Model B car would be 15 out of 80. And there's 40,000 cars that they're going to make, so they're going to want to keep this in the same proportion. So I'm going to have to multiply this by 40,000. Okay, so this is just another multiplication question at the end of the day. So when we've got a multiplication question like this on the non-calculator paper, something you could do is just, whenever you have a fraction, keep on simplifying it to make life easier for yourself. So 15 over 80, I know that I could divide that by 5, because 5 goes into anything that ends in a 5 or a 0. So 15 divided by 5 is 3. And 80 divided by 5, if I didn't know that off the top of my head, just use a quick bus stop method. So 5's into 8 go into once, and 5's remainder 3, 5's into 30 are 6. Okay, so I've simplified this to 3 over 16. And I need to multiply it by 40,000. What can I do? Turn it into a fraction, because to write anything as a fraction, you just write it over 1. And then you multiply the numerators. So 3 times 4 is 12. And then you add on your zeros, just to be sure. So 3 times 40,000 is 120,000. And 16 times 1 is 16. Once again, you're presented with a fraction. So what you could do is just simplify it. So I could just divide it by 2, so that would be 60,000 over 8, divided by 2 again, which would be 30,000 over 4, divided by 2 again is 15,000 over 2, and then we get a number that we can easily figure out. Anything divided by 2, you just half it, so that would be 7,500, and I don't know why the 7 looks like that, so 7,500. I mean, you could also have done it with using multiplication, but a really nice trick is just turning it into a fraction and simplifying it and simplifying, because it cuts out a lot of the work for you. Okay, so in this question, I'm told that Rizwan writes down 3 numbers, A, B, and C. The ratio of A to B is 1 to 3, and the ratio of B to C is 6 to 5. Now, I need to combine these and write it in the ratio A to B to C. So what I can do is write down what I know. I know that A to B is 1 to 3 and B to C is 6 to 5. So if you lay it like this, then you can see what the ratios have in common. Both ratios have B in common. So what you want to do is make your ratios equivalent. So if I multiplied this by 2, that would turn my ratio into 6, which is equivalent to the other ratio. Now, whatever you do to one part of the ratio to keep it in the same proportion you do to the other part. So 1 times 2 is 2, 3 times 2 is 6, and now that they're equivalent, I can write them as one big ratio. So that would be 2 to 6 to 5. Okay, so the key is finding what's in common and making them equivalent. So I know from the last part of the question that the ratio was 2 to 6 to 5. And that was an A to B to C. So I need to write A as a fraction of the total of the 3 numbers. So what do the 3 numbers total to? Well, 2 plus 6 plus 5 is 13. So I know it's going to be out of 13. What's the value of A? 2. So to write anything when you're dealing with ratio, you just write the ratio over the total. Now, this is a slightly trickier question that tends to catch a lot of people out. So let's have a think about what's happening. Emma writes down 3 numbers, M, N, and P. And we're told that N is equivalent to 2M and P is equivalent to 5n. So I have two equations, and whenever you've got two equations and you've got one variable or one letter in common, what you want to do is see if you can combine them. So I want my end result to have m and p in it. So the one thing that they have in common is n, and that's also something that I don't need. So I know that n is equivalent to 2m. So if I had the equation P equals 5n, what does 5n actually mean? It means 5 times by n. And I know that n is equivalent to 2m. So what I can do is substitute that into the equation. So I'm left with P equals 5 times by 2m. And now I've got rid of the n variable, and I'm just left with m and p. So I know that P is equal to 10m. Okay. Now, I want to write the ratio in the form m to p. So I need to think to myself, if I try to visualize this, what does it look like? Well, p, so 1p is equivalent to 10 lots of m. So if you just think about this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, p is 10 lots of m. So P is 10 times bigger than m. Therefore, the ratio would be 1 to 10, because P is 10 times larger than 10. Now, a lot of people write 1 to 10 because they get a little bit confused, but hopefully that visual helps explain that P is equivalent to 10 lots of m, therefore it is 10 times larger, because one little m is a tenth of P. Okay, so in this question, I am told that a storage tank exerts a force of 10,000 newtons on the ground. At the base of the tank in contact with the ground is a 4x2 rectangle, and I need to work out the pressure on the ground due to the tank. Now they've kindly given me the formula, so I know that pressure equals force over area. So what would I need to work out? Well, in order to work out the pressure, you need to work out the area of the part of the solid or whatever it is that is in contact with the table or the floor or whatever it is that you're trying to work the pressure out of. So I'm told that the base of the tank in contact with the ground is a 4 meters by 2 meters rectangle. So how do I work out the area of a rectangle? I just do base times width or height. So that would be 8 meters squared. So to work out the pressure, I do the force, which is 10,000 newtons, divided by the area, which I worked out as 8. Okay, now once again, what can I do? Just simplify it. So divide it by 2, that would be 5,000 divided by 4, divided by 2 again, 2,500 divided by 2, and then you're left with 1,250 newtons per meter squared. Now, if they didn't give you the units, the way to figure it out, you know that pressure is force over area, therefore the units have to be force over area. The force, you were told, is newtons, and area, well, you're working with meters, so you know it's going to be meters squared. Okay, so in this question, I'm being told that two numbers, m and n, are such that m is a multiple of 5. So I know that m has to be a number in the 5 times tables. Okay, so multiple of 5 just means a number in that numbers times tables. So I could just write out the first few multiples of 5. I know that n is an even number, so anything ending in 2, 4, 6, 8 or 0. I don't need to, I could write them out. It could be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, so forth. And I know that the highest common factor of m and n is 7. Okay, so for 7 to be a factor in it, it means that these numbers must be in the 7 times tables. So what I can do is just write out the 7 times tables. So that's 7, 14, 21, 28, 35, 42, 49, and so forth. Now, I want to find a value for m and a possible value for n. So the only condition is that m is a multiple of 5. So m has to be a multiple of 5, but also a multiple of 7, because 7 is a factor. It's one of the highest common factors of m and n. Therefore, m is a multiple of 7 because 7 is a factor of m. So any of these numbers that end in a 5, so 35 is my first number that ends in 5, therefore it's a multiple of 5 and is obviously a multiple of 7 because it's in the 7 times tables. And then I'm told that n is an even number, so what I need for n is for it to be an even number and also for it to be a multiple of 7. So the first even number that is a multiple of 7 is 14. Now, does this, so whenever you've got your values, think to yourself, does this actually work? What does it need to be? So for m, have I ticked the box that it's a multiple of 5? Yes. That it's a multiple of 7? Yes. And is the highest common factor of 35 and 14 7? So really quickly, we could just think, okay, 35, what are the factors? 1 times 35, 2 doesn't go into it, 3 doesn't go into it, 5 times 7. And then for 14, you've got 1 times 14, 2 times 7. So the highest common factor for both of these is indeed 7. So yes, for that. And then for m, is it an even number? Yes. And is 7 the highest common factor of it with 35? Yes. Okay, so there are 2 options, but you could have done a number of these. You could have done, for instance, 28 as your even number. Okay, so there's loads and loads of possibilities. This is just one of the ways. It's the simplest way, by just thinking logically, what are you being asked to do? Even if sometimes you write out information that later becomes irrelevant, it still gets your brain working and starting to process what the question is asking you to do. So m is 35 and n is 14. So in this question, I am being asked to complete the table of values for y equals 6x take away x cubed. It's always helpful to just think to yourself, what is the algebra doing? 6x means 6 is being multiplied by x, and then x cubed means x times x times x. Okay, so let's start with our first value. If x is 1, then y would be 6 times 1 take away 1 cubed. So 6 times 1 is 6, 6 take away 1 is 5. I can then do the same for the next one. So y would be 6 times 0 take away 0 cubed. Well, 0 multiplied by anything is 0. So that's just going to be 0. Then I've got negative 1. So y would be 6 times by negative 1 take away negative 1 cubed. And this is where it gets a little bit tricky because we're dealing with negative numbers. So negative 1 times by negative 1 is going to give you positive 1. But then when you times it by negative 1 again, it's going to give you negative 1. So a cube number is always, a negative number cubed is always going to be negative. So 6 times minus 1 is minus 6. And then I'm subtracting negative 1 from that. So whenever you're subtracting a negative, it's the same as adding, in case you may have forgotten. So minus 6 plus 1 gives me minus 5. And then I do exactly the same for negative 2. So I'm going to do y equals 6 times by negative 2, take away negative 2 cubed. So once again, 6 times negative 2 is minus 12, and I'm then going to subtract minus 2 cubed from it. So 2 times 2 is 4, times 2 again is 8. So that's going to be negative 8. So minus 12. And remember, when you're subtracting a negative, it's the same as adding. So minus 12 plus 8 gives you negative 4. So there you've got your table of values. So the next part of the question is just asking you to draw the graph, and you always do that from your table of values. So you start by plotting. Remember, you always plot the x coordinate first and then the y coordinate. So along the corridor and up the stairs. So along to 3 and then up to, down, sorry, to -9, and then along to 2 and up to 4. And then we've got, so just in case you weren't sure how to do the coordinates, this is the x value, 3, because it's along the x, and then the y value would be -9. So if you weren't sure how to translate a table of values into coordinates, that's how you do it. The x first, and then the y value. Then you've got 1 and 5. Then we've got 0, 0. Then -1, -5. Then -2, -4. And -3, 9. Okay, so as you can see, this isn't a straight line graph, and neither is it a quadratic. Just a quick recap: if it was a linear graph, it would look like a straight line. The key thing is it has to be straight. If it was a quadratic, then you know there's going to be that line of symmetry, so it looks something like that. But a cubic graph kind of does its own thing, because when you cube numbers, they can become negative. So it looks something like this. It's going to be like a weird little squiggle. So what you need to do is very carefully join all the plots together, but with a smooth curve. Okay, so not with a straight line, with a curve. That's really important. Okay, so in this question, I'm told that Lena spins a biased 5-sided spinner 40 times, and here are her results. Lena is going to now spin the spinner another 2 times, and I need to work out an estimate for the probability that she gets a score of 5 both times. So the first thing I want to do is work out what the probability of getting a 5 is. So the probability of getting a 5 is 10 out of the total number times that it was spun, which is 40. Okay, so to work out your relative frequency, it's always the total out of like your chosen thing. That's not the very scientific way to say it, but just to speak in layman's terms. So, the probability of getting a 5 is 10 out of 40, which we could simplify to a quarter. And I need to work out an estimate for the probability that she gets a score of 5 both times. So the probability of her getting a score of 5 on the first go, we could do a little mini probability tree, just to show you why I'm going to be multiplying over here. So on her first go, the probability of her getting a 5 is a quarter. And on the second go, the probability of her getting a 5 is also a quarter. And when you're dealing with probability, if you have the probability of this and that happening, it's the and rule, okay? So you multiply the probabilities together. And that's why when you have a probability tree, when you're going along a route, so you're imagining this is happening and that is happening, that's why you multiply the probabilities together. So what I'm going to do is a quarter times by a quarter, which is 1/6. Okay, in this part of the question, I'm told that Derek is going to spin the spinner a large number of times, work out an estimate for the percentage of times Derek can expect to get a score of 1. So what's the probability of getting a score of 1? Well, I know that when the spinner was spun 40 times, there was a 6 out of 40 chance of getting a 1. And what I want to do is turn this into a percentage. So the probability of getting a 1 is 6/40, and I now need to turn this into a percentage. There are a few ways you can do this. The quickest way is probably to think to yourself, okay, if I halved this, so if I divided by 2, I get 3/20, and then a percentage is always out of 100. So 20 is an easy number to multiply by to get to 100. So I just have to multiply by 5 for the numerator as well. So that would be 15/100, which is 15%. Whatever you did, you work out the probability of getting a 1 and then try and get that into a fraction over 100. Okay, so in this question, I am asked to describe fully the single transformation, that's really key, that maps shape P onto shape Q. So this question is one that is really easy to misread because everyone just assumes, oh, you go from Q to P because it's you know, left to right. It's also the smaller to the larger, but read the question very carefully. So I start with shape P and it gets transformed into shape Q, and it's a single transformation. Now, whenever a shape gets larger or smaller, you know that the transformation is going to be an enlargement. And we say it's an enlargement whether the shape's getting smaller or larger. So I know it's an enlargement. And what I want to do, and this is going to be a little bit tricky without a proper ruler, but what you want to do is to figure out, you know it's an enlargement, so that's step one. That's the transformation. Whenever you're talking about enlargements, you need to get the center of enlargement, so the point at which it is enlarged from, and you also need to get the scale factor, which essentially means how many times larger or smaller is the shape. So if I just take one side, this side of P is 3, this is 1. So what have I done to P to get from 3 to 1? I've had to multiply 3 times by a third, okay? Because 1 is a third of P. So the scale factor is a third. The scale factor is just literally how many times larger is the shape, or smaller in this case. So shape Q is a third of the size of shape P. So you get your scale factor, and then the next thing we do is find our center of enlargement. So to find our center of enlargement, I'm going to try and do this as carefully as I can. You get a ruler and you connect each corresponding point. So let's see if I can do this. That's not very good. So I've got a line there, and then I can connect this one to there, and then I can connect this one to this one, and then the last one is that one to that one. Okay, so this is really, really poorly done because I don't have a ruler, but if I did have a ruler, over here is where all of the lines would meet. Okay, so where all the lines meet is your center of enlargement. So the center of enlargement is, let's just get rid of these lines so I can see where it is. Okay, so the center of enlargement is 0, 2. Okay, so when you're doing transformations and you're talking about enlargements, it's really important you name, step one, name the transformation. If it's an enlargement, you have to say what the scale factor is and also what the center of enlargement is. And that's how you can get your full marks. Okay, so here I'm being asked to solve the simultaneous equations. Now, whenever I solve a normal linear equation, I end up with one answer, so x equals y equals. When I'm solving simultaneous equations, that means I've got 2 variables and 2 equations, therefore I'm going to have 2 answers, one for the, in this case, x variable and one for the y variable. And the key thing to do with simultaneous equations is to make one of the variables equal so that we can eliminate. So it's up to you which you choose. I am probably going to go for the y variable because it's just multiplying by 2 and 3, but you could eliminate the x. It's totally up to you. So I look at this variable and I want to make them equal. In order to make them equal, what I'm going to have to do is find the lowest common multiple. So lowest common multiple of 2 and 3 is 6. So therefore, what do I do to 2 to get it to 6? I multiply 2 times by 3, and I multiply 3 by 2. Okay, so that would end up with 6y. Now, because I'm changing part of my equation, I have to make sure I multiply each part of my equation by the same amount so that it stays in the same proportion. So let's multiply the first one over here. So 5x times 3 would give me 15x plus 6y equals 33. And then 4 times 2 is 8x, 3 times 2 is 6y, and 6 times 2 is 12. So now you've got your simultaneous equations and you've got a variable in common because 6y appears in both equations. So what I can then do is eliminate that variable because it's common to both of them. To eliminate it, I want to get rid of it. So in this case, how can I get rid? If I've got 6 and 6, how can I eliminate it? I can subtract, because 6 takes 6 gives you 0. Okay, so you've eliminated the y variable, it's no longer there. And you subtract the rest of the equation too. So 15 x take away 8x is going to leave you with 7x, and 33 take away 12 is 21. So once you know that 7x equals 21, you solve it to find the value of x. So divide both sides by 7, x equals 3. So you've got your first answer, x equals 3. Now you know that the value of x is 3. So what you do is you choose one of the equations, it doesn't matter which, and you substitute the value of x into it. So let's just go for the first one. If x is 3, 5x is going to be, well, let's just write it out like this. 5 times x plus 2y equals 11. So 5 times 3 plus 2y equals 11. Therefore, 15 plus 2y equals 11. So to isolate now, I'm trying to isolate y. In order to solve it, I'm going to have to subtract 15 from both sides. So 11 take 15 gives me minus 4. Therefore, 2y is minus 4. And to get y on its own, I'm going to divide both sides by 2. So y is negative 2. Then you have an answer for your x variable and your y variable, and you've solved the simultaneous equation. Okay, in this question, I'm being told that P is inversely proportional to T. Now, when something's inversely proportional, it just means that as one value goes up, the other value goes down. So unlike direct proportion, where you'd expect a nice steady straight line, inverse proportion is like a little curve. So I can write this as a little statement. So T is inversely proportional to T. Sorry, that should be P. Now, this little fisheye statement here, hopefully you've come across it before, but if not, this literally means is directly proportional to. And the inverse of anything, so if T is my given value, the inverse of T is 1 over that thing. Because the inverse of anything is the fraction flipped, and if T was a fraction, it would be T over 1. So the inverse of it is 1 over itself. So this statement just reads, P is directly proportional to the inverse of T. Now, you don't have to write this statement, but it just sometimes helps to just write it down like this. You then form an equation where P is equal to K over T. And then you can substitute your values in. So I know that when P is 1, T is 100. Okay, so I've substituted my value of P and my value of T into this equation, and I can now solve it in order to find out what the value of K is. So K must be 100. Once I've figured out what my value of K is, I can use that to figure out the value of anything else. So I write the general formula, P must equal 100 over T. So all I've done is I've worked out the value of K and I've substituted it into this formula. So this is now a general formula I can use for any value. So I can start with when T is 25, what would I do? I would do P equals 100 over 25, which is 4. Then I can do the same for when P is 5. So I'd say 5 equals 100 over T. I rearrange the equation, so 5T equals 100, and therefore T must equal 100 divided by 5, which is 20. And then for the last bit, I do exactly the same. So when T is 2, I substitute into this general formula. P is going to be 100 over 2, which is 50. Okay, so inverse proportion. If this is something you've never come across, then watch the full video because it explains it in a lot more detail and why you're forming these formula and so forth. Okay, so in this question, I am being given some information about the weights of some potatoes. And then I'm being asked to draw a histogram for this information. So the really key important thing to know with a histogram is that in order to work out your frequency density, which is always going to be the y-axis, your frequency density is the frequency divided by the class width. Okay, so I'll explain what that means just briefly in case you didn't know. Frequency is literally another word for the amount. So the amount of potatoes in this case. So the frequency for the first part would be 20. And the class width, you look at your class interval here, and you basically, what's the largest value, take away the smallest value. So the class width here is going to be 20. So let's see if I can plot that for my first thing. So to work out the frequency density, for the first part, I'm going to do 20 divided by 20, which is 1. So I know for my first bar, the frequency density, I could do another column here, the frequency density is going to be 1. Let's work it out for the next few as well. So the frequency density is going to be 50, because you do frequency divided by class width. 70 to 80 is a class width of 10. 50 divided by 10 is 5. So your frequency density for this is going to be 5. Let's do exactly the same for the next two. So you've got a frequency density is going to be your frequency, 60, divided by your class width, which is 10. 60 divided by 10 is 6. So your frequency density here is going to be 6. And then for the last part, you've got 30. Frequency divided by 20. So 30 divided by 20 is going to give you 3/2 or 1.5. So now you've worked out what all of your frequency densities are, you can come up with an appropriate scale. You know, your largest value on your y-axis is going to be 6. So let's have a look at how many boxes there are. And then we can think of an appropriate scale. So there's 1, 2, 3, 4, 5, 6, 7 large boxes. So it probably makes sense to just do my scale as 1, 2, 3, 4, 5, 6. Okay. Now when we're drawing our frequency diagram, our histogram, what we do is the bars, the width of them is going to be the class width. So it starts at 50 and it ends at 70. So you know your bar is going to be that width, and it goes up to the height of our frequency density. So our first bar is going to have a class width of 20 and a frequency density of 1. So I'm going to draw it like that. Okay, that's your first bar. And really quickly, just so that you are aware, the frequency is always going to be the area of the bar. So to double check you've got it right, what's the area of the bar? Well, the width is, or the base is 20, the height is 1, 20 times 1 is 20. So yeah, I know I've done it right. Then let's do our next one. So for our next one, the frequency density is 5 and the class width was from 70 to 80, so a width of 10. So go up to 5 and then that is my next bar. Let's just double check. 5 times 10 is 50, which is my given frequency. Then let's do the next one. So the frequency density is 6. So it's going to go up to 6. And my class width was from 80 to 90. So it's just going to be a class width of 10. So I go up to 6 and I shade that one in. Double check. 10 times 6 is 60. So that is the given frequency. And the last bit for the last column, you've got a frequency density of 1.5. So it's going to be here. And a class width from 90 to 110. So you go to 1.5, 110, and you just draw that in. And that's how you would fill in your frequency, your histogram. Sorry if I keep on saying frequency diagram. Hopefully I haven't said that. Your histogram. And those are your frequency bars. Okay, so for this question, I'm told that the diagram shows a sector of a circle of radius 18 centimeters. I'm told that the length of the arc is 4 pi centimeters. So an arc, just in case you may have forgotten, is just a part of the circumference of a circle. So this would be an arc, okay? and I know that that arc length is 4 pi. This is a non-calculator question, so likely I might leave my answer in terms of pi. I need to work out the value of x, which is the angle of the sector. Now, in order to do this question, you need to know a formula for how to work out the arc length. So the formula for the arc length is, well, how do you work out the circumference of a normal circle? You know that the circumference of a circle is pi times diameter, and an arc is just a fraction or a part of the whole circumference. So therefore, you're going to multiply the whole circumference, which is pi d, times by a fraction of the circle. And that fraction is the angle of the sector, okay? So over here, we're not given that angle, but I'm just going to call it theta. So theta is just a way, this is the sign for theta, and it just represents an angle. I could use x if I like, but just as a general rule, it just helps if you remember this is theta and that's the angle. So I do the angle out of 360 because that then gives me a fraction of the circle. For instance, just to briefly illustrate this, obviously if it was a quarter of a circle, the circumference of a circle is pi times diameter, and I times that by 90 over 360, which simplifies to a quarter, which is why you would just divide the circumference by a quarter to work out the arc length of a quarter of a circle. But translate that to something that isn't a nice 90-degree angle. That's why we do the angle over 360. Okay, so the formula for arc length, if you didn't know it, just write it down, is pi d times by theta over 360. So if I know that, what I can do is substitute the values that I've been given. So I've been told that the arc length is 4 pi. I know that the radius is 18. And I know that diameter is double the radius. Okay, so remember in a circle, the radius is from the center to the outside, and the diameter is from the center to from one edge of the circle to the other. So it goes through the center. So it's essentially 2 lots of the radius. So therefore the diameter is going to be 18 times 2, which is 36. So I can substitute that into my equation because the diameter is 36. I don't know what x is, so I'm just going to leave that, but I know that it's over 360. So let's just clear a bit of this up so that we can simplify things a little bit further. So let's see what we can do here. I know that 4 pi equals pi times by 36 times by x over 360. Now what I can do, because all of this, if I turn them into fractions over 1, I could write them as one big fraction. So the numerator would be 36 pi, and I'll just write it as times by x just to keep it separate, but you could write it as 36 pi x because with algebra you don't write the multiplication. So 36 pi times by x over 360, because when I multiply fractions, I multiply the numerators and then I multiply the denominators. So I know that 4 pi equals 36 pi times by x over 360. What I could do is then times both sides by 360. So 4 times 360, remember when we're doing non-calculator, we can use the double and halving rule. So double one and halve the other. So 2 times 720 is slightly easier to do. 2 times 700 is 1,400 and double 20 is 40. So you'd be left with 1,440 pi equals 36 pi times by x. Okay, now what can you do to isolate x? We could divide both sides by 36 pi. So 1,440 pi divided by 36 pi is going to give me x. Now let's see what I can do to simplify this fraction. Whenever I've got a fraction and things are being multiplied, so pi is being multiplied by 1,440 and it's being multiplied by 36, anything divided by itself is itself, like 5 divided by 5 is 1, so I could just cancel out the pi. So I'd be left with 1,440 over 36 equals x. And then what do? Once again, I've got a fraction, so I just need to simplify that. So I could divide it by 2. So 1,440 over 36, let's divide it by 2. That's going to be 720 over 18. I can divide it by 2 again, 360 over 9. Now I can't divide by 2, so let's think of what I could divide. I could divide by 3, which is the next prime number. So that would be 120 divided by 3, and then you get to the part where you can just work it out. So 120 divided by 3 is 40. Therefore, x is 40 degrees. So this is a slightly more difficult question because it requires a lot of manipulation, but as long as you know your formula and you substitute some values in, you're off to a great start. And then just see how far you can go by manipulating the algebra. So in this question, I am being asked to prove that this expression equals this expression. Okay, when you're being asked to prove something, that means show every step of your working and have a logical line of working. So what you want to do is show everything you're doing. Now, I've got 2 different expressions that have been factorized in slightly different ways. So what can I do? I can just expand the brackets. Okay, so let's start with this. I've got 2m plus 1 squared. Okay, so let's just expand that bracket quickly. That's going to give me 2m times 2m is 4m squared. 2m times 1 is 2m. 1 times 2m is 2m. And 1 times 1 is 1. Can simplify that to 4m squared plus 4m plus 1. Okay, so I know that that's simplified, and I don't have as much space as you will. Try and rather prove that question right small, because sometimes they might be quite extensive. So I know that this bracket here simplifies or expands to 4m squared plus 4m plus 1. So now what I want to do is expand the next bracket. So 2n take 1 squared is going to be 2n take 1 multiplied by itself. So let's have a go at that. 2n times 2n is 4n squared. 2n times minus 1 is minus 2n. Minus 2n, and then a negative times a negative is a positive, so it's plus 1. Simplify that, so you've got 4n squared minus 4n plus 1. So you were subtracting this whole expression, 4n squared minus 4n plus 1. Okay, so let's deal with that first. Now, this line of working, so you've shown that this expands to this and this expands to this. Now we need to look at how we can simplify that. So let's just write it out again. How could I simplify that? Well, 4m squared, there's nothing in common. So I'm going to write 4m squared minus 4n squared because I'm keeping all the powers the same. Or actually, no, let's not do that because that might be a bit confusing. I'm just going to think about what I'm going to do with these terms. So because I'm subtracting a negative, that means that I'm actually adding. So remember, when you're subtracting a negative, it's the same as adding. If that confuses you slightly, then whenever you've got a full expression, you're subtracting a collection of terms and you're not just subtracting one term. Just put a bracket over it and put a negative 1 because you're subtracting it. So you're subtracting the negative version of it. So it's the same as having negative 1 in front of the bracket. So that would effectively be, let's just write out the rest, minus 4n squared, and then minus 1 times by minus 4n, or minus 1 take 4n, is going to give me plus 4n, and then minus 1 times 1 is minus 1. Okay, so you choose whichever way works better for you. If you're confident subtracting the terms individually and you know you're subtracting a negative and therefore it's going to be a positive, just do that. If not, when you're subtracting an expression, so a collection of terms, put it in a bracket and then put a negative 1. I mean, you've already got a negative, just stick a 1 in front of it and expand the bracket like that. So then this side of my equation I have shown simplifies to this, expands to this. Now I can also simplify this further, so I could write it as 4m squared plus 4m, take 4n squared plus 4n, because 1 take 1 is going to cancel out. So this is what this side of my expression simplifies to. And now let's have a go at the next side. So let's put a little thing here. And then I'm going to have to expand this bracket. So 4 times m is 4m, 4 times n is 4n. And then you're going to have to multiply that by this bracket here. Okay, so I've expanded this to make it a full bracket, and I can just multiply the brackets out again. So 4m times by m is going to give me 4m squared. 4m times by negative n is going to be negative 4mn. 4m times by 1 is 4m. And then 4n times by m is plus 4mn. 4n times by negative n is negative 4n squared. And 4n plus 1 times 1 is 4n. Okay, so what I want to do is simplify this. Well, I know that negative 4mn plus 4mn is going to cancel itself out. So I could rewrite that as 4m squared plus 4m minus 4n squared plus 4n, which is exactly the same as the other side. Okay, so when you're proving something, you just expand it, you just manipulate it, you simplify it until one side equals the other, or until you've proved what you're trying to prove. Okay, so in this question, I am told that Sophia says that the result in part A, which was this, so if you just flick back to the last question, we proved that both sides expand to make this expression. So the result in part A shows that the difference of the squares of any two odd numbers must be a multiple of 4. Is Sophia correct? And give a reason for your answer. Now, this is a reasoning question. Whenever you're asked something like this, you need to explain it in words and explain your reasoning. So just a quick recap or overview of how to prove anything is an odd or an even number. If you take any number, let's call it m. So m could be 1, it could be 2, it could be 3, it could be 500. Doesn't matter what it is. If I doubled it, I would then make an even number, because multiplying anything by 2 or doubling anything doubling any integer, so any whole number, turns it into an even number. Okay, so whatever m is, whether it's odd or whether it's even, if it was 3, I double it and it becomes 6, which is even. If it was 4, I double it and becomes 8, which is even. So if I double anything, I am certain that this must be an even number. Anything that is doubled is an even number. To then make sure that it's odd, once I know it's an even number, I can either add 1 or subtract 1. And therefore I've proved that it's an odd number. So 2m plus 1 must be an odd number. And this is an expression for an odd number, which is what they've used here. And 2n minus 1 must also be an odd number, because whatever n is, if I double it, I turn it into an even number. If I subtract it, it's an odd number. So I have an expression for an odd number and an odd number. And Sophia says, show that the difference of the squares of two odd numbers, okay? So this is an expression for an odd number, and I have squared it, and I'm subtracting them. So whatever this is, odd number squared, take away the other odd number squared, gives me 4m squared plus 4m, take away 4n squared plus 4n. Now, does an odd number squared take away an odd number squared mean that the answer has to be a multiple of 4? Well, let's think about it. Can I factorize this? Is there anything in common with each of the terms? Yes, I can take out 4. So that would become 4m squared plus m, take n, plus n, sorry, take n squared, okay? And because you factorize the 4 out, you show that 4 is a factor of it. Therefore, any answer must be a multiple of 4. So you try and explain that in your own words as well as you can, but essentially just explaining that this is an expression for an odd number, and factorizing this side to show that it's a multiple of 4. Okay, next question, we're dealing with fractional indices. So whenever you've got a fractional indices, the denominator always tells you what root it is. So if it's a 2, it would be the square root. In this case, it's a 3, so it's the cubed root. And the numerator tells you what it's going to be to the power of. So just to quickly do a little brief. So if I had 8 to the power of a third, that shows me it's the cubed root. So I'd write that as the cubed root of 8, which is 2. Okay. If I had 8 to the power of 2 over 3, I would cube root it. So it'd be the cubed root of 8 to the power of 2. So that would become 2 to the power of 2, which is 4. Okay, so quick overview of the fractional indices. Now let's see what happens here, because I've got a fraction being put to the power of a fractional indice. So 8 over 27 to the power of 4 over 3. I'm going to deal with the denominator first, and this is telling me that everything is being cube rooted. So I can write that as the cubed root of 8 over the cubed root of 27, which then I need to do to the power of 4. What is the cubed root of 8? The cubed root of 8 is 2. Now the cube numbers are things that you need to know off by heart. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. At least these you need to just know off by heart. So if you don't, then write them down immediately. And 5 cubed as well. Okay, so anyway, cubed root of 8 is 2, the cubed root of 27 is 3. Okay, so you've just simplified that, and it's still going to be to the power 4. And then you work out what 2 to the power 4 is. So what does the power 4 mean? It means 2 is being multiplied by itself 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. And then you've got 3 to the power 4. So 3 times 3 is 9, times 3 is 27, times 3 is 81. If you didn't know that off by heart, then you could just use any multiplication method you like. But there we go. We've worked out the value of the question, which is 16 over 81. Okay, so here I've got a question on circle theorems. Now, this kind of question is generally one that people seem to freak out about. But when you've got a question like this, or any question that seems a little bit difficult, just think to yourself, what do I know? Okay, so let's have a read through the question. It tells me that A and B are points on a circle centre O. DBC is the tangent to the circle at B. So that's a really key word that should spring to mind one of the circle theorems, which is that a tangent meets the radius at 90 degrees. Okay, so this is one of the circle theorems. A tangent and a radius form perpendicular lines. Therefore, they form a right angle. So that's a really key thing that we're going to probably use. But even if we don't, at least you've written something down and you're starting the question. So the tangent meets the radius at 90 degrees. Therefore, I know that this angle here is going to be 90, and also this angle here, but that's split into 2. So let's not worry about that for now. I'm told that AOB equals x degrees. So this angle here is x. And I need to show, which means I need to show each little step of my working in a logical and reasonable way. that ABC, so ABC is going to be this angle here. I need to show that that is a half of x. Now, what a lot of people tend to do is they try and work backwards, which sometimes backfires. So when you've got to show that question, start from the beginning and then work your way through it, and hopefully your answer will be the same as what you're trying to get to. So let's start at the beginning. So first of all, I know that a tangent meets the radius at 90 degrees. Therefore, I know that this whole angle here, angle OBC, so therefore angle OBC equals 90 degrees. Okay, so that's a little first part of my working. The next thing, and this is another bit that really should be spoken about a lot more. So people tend to memorize all of the circle theorems and then they forget that they can actually form things by themselves from their basic knowledge of circles. So whenever you have a triangle that is formed by two radii is just a plural of radius, you know that this is the center of the circle and it goes to the outside, so that's a radius. And this is the center and that's the outside, so this is also a radius. Okay, so whenever a triangle in a circle is formed by two radii, it is an isosceles triangle. And the key thing about an isosceles triangle is that the base angles are equal. Okay, so if I know this, I can start to form an expression for what the base angles must be. So this angle here and this angle here are going to be equal. Now, what do angles in a triangle add up to? Angles in a triangle sum to 180 degrees. Therefore, angle OBA and angle OAB must equal 180 take away x. Okay, because I know that all of these angles sum to 180. Don't know what x is, but x plus this must equal 180. Now, I've already briefly mentioned that we've got an isosceles triangle here. So with an isosceles triangle, let me just say why it is an isosceles triangle. It's a triangle OBA is formed by two radii, therefore it is isosceles. And an isosceles triangle means that these two angles are going to be equal. So if I know that this plus this is 180 take away x, how could I work out what one of them is? Well, I'm just going to divide it by 2. So this angle here must be 180 take x over 2. So if I know that that angle, this part of the angle here is 180 take away x, my final result, I'm trying to work out what this, what angle ABC is. So this part. I know that the full angle is 90 degrees because the tangent meets the radius at 90 degrees. So to work out what this part of this 90 degree angle is, I'd have to do 90 take away 180 take x over 2. Now you can do this however you like. I'm just going to clean this up a little bit just to show you how the algebra would work. I'm only getting rid of these reasons to make space. You obviously must write your reasons. The more reasons you write, the better. Just write everything you can. So how could I simplify this? Well, I could just first of all write it in 2 fractions. So 180 over 2, take x over 2. Let's simplify that further. 180 over 2 is 90. So I'd be left with 90, take away x over 2. And if you've watched this whole video all the way through, then you remember When you're subtracting an expression that has more than one term, you need to be super careful. So you can put it in a bracket and put a -1 in front of it and then expand the bracket, or just be mindful that if you're subtracting a negative, you end up adding it. So that would give me 90. -1 times 90 is minus 90. -1 times -x/2 is going to give me +x/2. And then just simplify the expression even further. 90 take 90 simplifies to 0. So therefore angle ABC must equal x/2, and x/2 I can write as a half times by x/1. So therefore angle ABC equals a half x. Okay, so the last bit is just trying to simplify it, just trying to subtract your expression from 90. And the rest of it is just listing the circle theorems. Obviously, there's loads of ways and loads of routes you can take through this question. This is just one of the ways to get you thinking about how to use the circle theorems. Okay, so we've got a nice algebraic fractions question. I'm told to solve 1 over x, take away 1 over x plus 1 equals 4. And to give my answer in the form a plus or minus b root 2, where a and b are fractions. So let's have a go. First of all, what is the rule I need to always have in mind? Whenever adding or subtracting fractions, they need to have the same denominator. Okay, so that's the key rule. Whenever adding or subtracting fractions, they need to have the same denominator. So just because it's an algebraic fraction doesn't mean any different. I'm going to look at my two fractions and find the lowest common multiple. Now, generally, with an algebraic fraction, the lowest common multiple is going to be the denominators multiplied by each other. So the lowest common multiple in this case would be x over x plus 1. If you know you're multiplying the two denominators by each other, you know that you can cross multiply. So this just speeds things up once you've got into the habit of doing this, but we'll take it the slow way just in case. So what would I do? I'm trying to simplify these fractions. I know that their lowest common multiple is x plus 1 because it's just a common multiple of them. If in doubt, you can always just multiply the denominators and that gives you a multiple. So you've got x bracket x plus 1. Now what have I done to this fraction, to the denominator, in order to turn it into x plus 1? I've multiplied it by x plus 1. So therefore I have to do the same to the numerator. So I'm left with x plus 1. What have I done to this fraction to turn it into this denominator? I've multiplied it by x. So I'm going to need to do the same to the numerator. Okay, so now I've got two fractions that have the same denominator. And once they have the same denominator, I can just subtract them. So I could just do x plus 1, take x as my numerator, and my denominator stays the same. Okay, now what I want to do is simplify the numerator. So x take x cancels. So I'm left with 1 over x plus 1. Okay, so I've simplified my fractions now. I've dealt with this side of the equation. I've just subtracted the fractions and simplified. So therefore this side of the equation equals this. So now I can come back to solving it. So I'd say this equals 4. Okay, so step 1, add or subtract your algebraic fractions in order to just make your life a lot easier. And then we can get back to the solving. So I know that 1 over x plus 1 equals 4. And I know I need to solve this. Now, when I'm solving any equation, it means I want to isolate the x variable to figure out what its value is. This looks like it's going to be a slightly trickier one, and it looks like it's going to have a quadratic in it. So what I want to do is, let's see what I can do with the denominator. Let's expand it. So 1 over x squared plus x. I've just expanded the bracket out. must equal 4. I want to then manipulate it so that I get a nice quadratic. So I'm going to multiply both sides by x squared plus x. And I end up with 1 equals 4x squared plus x. I can then expand the bracket. So 1 equals 4x squared plus 4x. And whenever I've got a quadratic, in order to solve a quadratic, you have to always make it equal to 0. So in order to solve a quadratic, you must make it equal to 0. So just rearrange it and make it equal to 0. So what am I going to do? I'm just going to subtract 1 from both sides. So I'd be left with 4x squared plus 4x, take 1 equals 0. Okay, so I've got a quadratic. Now, I could factorize it, but the fact that it's told me that I need to give my answer in surd form tells me I'm most likely going to be using the quadratic formula. So what is the quadratic formula? It's given to you on your formula sheet. So x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Best thing to do when you're using your quadratic formula is realize that every quadratic is written in the form ax squared plus bx plus c, where a is going to be the coefficient of x squared, b is the coefficient of x, and coefficient just means the number attached to the letter, and c is -1. So I'm going to substitute these values into the quadratic formula. So minus 4 plus or minus the square root of 4 squared, take away 4ac, so a is 4, c is -1, over 2a. So let's simplify that where I can. 4 squared is 16, 4 times 4 is 16, 16 times -1 is -16, over 2a. So that would give me -4 plus or minus the square root of 32, because when you have two negatives next to each other, you add them. Subtracting a negative is the same as addition, over 2a. And I haven't actually substituted a, so a is 4, so 2a would be 8. Okay, so let's continue simplifying that. Okay. When you've got a surd, you're most likely going to want to simplify it. So let's just quickly simplify the square root of 32. How do you simplify a surd? You look for the largest square number you possibly can find inside the surd. So if you need to, list the square numbers. You've got 1, 4, 9, 16, 25, 36. Do any of them fit into your surd? Yes, 16 does. So I could rewrite that as root 16 times by root 2. And what is root 16? The square root of 16 is 4. So that is 4 root 2, which I would simplify like that. Okay, so I've rewritten the square root of 32 as 4 root 2 over 8. Okay, now I can simplify this. And if you struggle a little bit with doing simplification, what you can do is just turn it into two fractions, okay? Just split it up. So you'd be left with -4 over 8 plus or minus 4 root 2 over 8, okay? You've just split it up. So, -4 over 8 is -1/2, and then 4 over 8 is 1/2, so that would be root 2 over 2. And your answer needs to be in the form a plus or minus b root 2, where a and b are fractions. So we could just rewrite that. Actually, I didn't need to do that. as a half plus or minus a half root 2. It's the same thing. A half times by root 2 over 1 is the same as root 2 over 2, but just because they said where a and b are fractions, a is going to be negative a half and b is going to be positive a half. Okay, so over here I've got a question that says that Alfie has 11 cards. 3 of them are blue, 7 are green, and 1 is white. And then told that Alfie takes at random 2 of these cards, and then I need to work out the probability that he takes cards of different colours. So this is going to be a big probability tree. So get ready. We're going to start with card 1. Okay, so card 1 could be blue, it could be green, or it could be white. So let's just work out what the probabilities of that would be. Probability is always, so for blue it would be 3 out of the total is 11. For green it would be 7 over 11, and for white it would be 1 over 11. Okay, so let's fill that in for my probability tree. 3 over 11, 7 over 11, and 1 over 11. Then for my second card, card 2, I could take a blue card, another blue card, or I could take a green card, or I could take a white card. I could also, if I've taken a green card, I could then take a blue card, or a green card, or a white card. And for white, if I've taken my white card, I could then choose a blue card or a green card. I don't have an option to take a white card because there's only one white card. So if I've taken it, there are no more white cards to take. So this is not a replacement question. He takes 2 cards at random. So once he's taken 1 card out, there were 11, there are now 10. So you need to make sure that all of your denominators are out of 10. Then what we can do is think about the probabilities. So if you've taken a blue card already, you've taken 1 away, so the probability would be 2 over 10. The probability of green would be 7 because you haven't done anything with that 7, with that green card, and the probability of a white card would stay the same. If you'd taken a green card, the probability of then choosing a blue card would be 3 over 10 because you haven't touched the blue cards. The probability of getting a green card would be 6 over 10 because you've already used one of the green cards, and for white it would be 1 over 10 because it hasn't changed. Similarly, for a blue card, if you've taken your first card was white, then the blue card would be a probability of 3 over 10 and green would be 7 over 10. So what is the question asking me to do? It's saying work out the probability that he takes cards of different colours. So let's see, I've never used a highlighter before. Let's see if it works. So different colours, what option could I take? I could go blue and then green. Okay, that's one option. Or blue and then white. Or green and then blue. Or green and then white. Or white and then blue and then white and green. Okay, so those are my routes that I can take. So let's see what they would end up being. So if I went along, so really quickly recap on the basics of the probability tree, you need to make sure that your branches always sum to 1. And when you go along the probability tree, you just multiply your probabilities. So this route would be 3 over 11 times by 7 over 10. This route would be 3 over 11 times by 1 over 10. And then this route, green and then blue, would be, ooh, I'm running out of space. That would be 7 over 11 times by 3 over 10. And this route here would be 7 over 11 times by 1 over 10. And then over here, it would be 1 over 11 times by 3 over 10. And finally, 1 over 11 times by, is that 7? 7 over 10. Okay, so those are your probabilities. We need to work them out. So we know that all of our denominators are going to be over 110 because 11 times 10 is 110. So that's a quick, nice and easy fix. And then just multiply your numerator. So 3 times 7 is 21, 3 times 1 is 3, 7 times 3 is 21, 7 times 1 is 7, 1 times 3 is 3, 1 times 7 is 7. Okay, so with a probability tree, once you've drawn it, make sure all of your branches sum to 1. That's how you know you've done it right. So 3 plus 7 plus 1 is 11. So 11 over 11 is the total probability. Here, 2 plus 7 plus 1 makes 10, 10 out of 10. That's double checking your branches. And then when you go along, you just multiply. Just reiterating it so it sinks in and you never forget. Once you've done that and you've worked out all of your possible roots, so it could be this root, or 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 this root. Remember the OR rule in probability when you are presented with options. So you could take this option or that option, you add the probabilities together. Okay, so the AND rule, you multiply. That's why we multiply along the branches. So you could take a blue card and a blue card. That's why you do 3/11 times by 2/10. And then once you've got to your options at the end, you add them all together. So 21 plus 3, or let's do the big numbers first. 21 plus 21 is 42. 42 plus 7 is 49. Plus 7 is 56. Plus 3 is 59. Plus 3 is 62. So your final probability would be 62 over 110. You've not been asked to simplify it, so you can just leave it like that. Okay, so as part of your knowledge of trigonometric graphs, you should recognize or be able to sketch the graph of y equals cos x. So let's just quickly sketch what that would look like here. Y equals cos x starts over here, it dips, and then it goes back up, and that's the 360-degree loop. So the normal y equals cos x graph, the y-axis maximum point is 1, the minimum point is always -1, and a cycle goes through 360 degrees. So this would be 360 over here, this is 180, this would be 90, and 270, and so forth. Okay, so you should be able to sketch that graph and be familiar with it. So in this case, we are told the diagram shows a sketch of part of the curve with the equation y equals cos x. So you know this is the y equals cos x graph. P is a minimum point on the curve. Okay, write down the coordinates of P. So all we need to do is think of our y equals cos x graph. You know that this would be the first section. Okay, so this is just another squished down version of this. So I know that this point here would be 360. The halfway point is 180. Therefore, P, the x coordinate, is going to be 180. And the y coordinate, I know that the peak and the trough is 1 and -1. So the y coordinate would be -1. Okay, so in this triangle, I'm told there is a triangle ABC. I need to work out the value of sine ABC. So sine ABC is this angle here. And I need to give my answer in the form m over n, where m and n are integers. Remember, integers just mean whole numbers. So I'm clearly going to leave my answer as a fraction, which is totally fine. So this is the angle I'm trying to find. Now, whenever you're dealing with triangles, you know that you're going to be dealing with Pythagoras, trigonometry, sine rule, cosine rule, blah, blah, blah. If it is not a right-angled triangle, so if it is a right-angled triangle, you know that you can use trig or Pythagoras. This one is not a right-angled triangle, therefore those go out of the window. So I know I'm going to be using the sine rule, the cosine rule, or area of a triangle. Let's actually look at what's going on. So I've got my triangle. Whenever you have a non-right angled triangle, one of the best things you can do is label your triangle. So always label it according to the given angle. So this is the angle that we have been given. We can call that A. And therefore this side is going to be little a. So remember with trigonometry, the big side represents the angle. So the big letter, and the little letter represents the side. And they're always going to be opposite each other. So we can label that A. Therefore, this angle here would be C and this side would be C. And this angle here is B. And this side here would therefore be B. Remember as well, in this case, they've been super nice and the triangle is what it says it is. But you can rewrite it just because they've called it ABC. You can change it and you can make it work for you. In the next question, when that's relevant, I will make sure to highlight that. But for now, let's just go along with it. So what can I do? Well, I've been given an angle and two sides, and I'm trying to figure out a final angle. So the sine rule is going to come in really handy. Now, if you are not super familiar with the sine rule, really quickly, it is just A over sine A. Oopsie, sorry, already gone wrong. A over sine A equals B over sine B equals C over sine C. All this means is that a little side, so this side here, divided by sine this angle here, is equivalent to side B divided by sine B angle. So that might not make any sense. If you've never done this before, then watch the video on the sine rule separately to familiarize yourself, but just a quick recap of the sine rule. And obviously you can flip it, so you could get it to be sine A over A equals sine B over B, and so forth. You decide which way you want to use based on what information you've been given. So let's have a look at the information that we've been given. I know sine A and I know side A, and I want to figure out sine B, this angle here, and I've been given side B. So let's substitute that in. So sine 30, because angle A is 30 degrees, over side A, which is 10.7, must equal sine B, which is what I don't know. I don't know what sine B is, over B, which is 6.5. Okay, so all I've done is I've substituted the values from the triangle into the sine rule. And I chose to do it this way round because my subject, what I'm trying to find is the numerator. It's just a lot easier to manipulate it, but it's not the end of the world if you did it the other way around. It's just a little bit harder. So what can I do? Well, as part of the new GCSE, it's not that new anymore, but you need to know your exact trigonometric values. So you are expected to know what the value of sine 30 is, which is 0.5 or a half. So we can substitute that into here. So I've got 0.5 divided by 10.7 equals sine B over 6.5. I could clean that up a little bit. So 0.5 divided by 10.7, this is non-calculator, so I can write it like this. 0.5 divided by 10.7, I could turn 0.5 into a fraction, divided by 10.7, I could also turn that into a fraction. What do you do when you divide fractions? You keep, change, flip. So a half times by 1 over 10.7 gives you 1 over, and then 10.7 times 2 is 21.4. So you know that 0.5 divided by 10.7 is 1 over 21.4, and you know it equals sine B over 6.5. So we can manipulate the formula, rearrange things in order to get sine B isolated. So I can times both sides by 6.5. So I'm left with, let's get rid of all of this. I'm left with 6.5 over 21.4 equals sine B. Okay, remember when you're multiplying fractions, you just multiply the numerator. That's the same as timesing by 6.5 over 1. So they told me that they wanted my answer to be in the form m over n, which I've done, 6.5 over 21.4. But they've also said they want m and n to be integers. So what I'm going to have to do is multiply them to turn them into whole numbers. So if I times the fraction by 10, I end up with 65 over 214. And there we've got my final answer. So sine ABC must equal 65 over 214. So all this question is asking you to do is quite a few things, but all you're essentially doing is substituting into a formula and rearranging it. Okay, so in this question, I'm told that here are the first 5 terms of a geometric sequence. And this is a really key piece of information because a geometric sequence is where you multiply or divide to get from one term to the next. Okay, so a really basic geometric sequence, just to give you a recap, is this. What do I do to get from one term to the next? Well, I know a geometric sequence, I need to multiply or divide by something. How do I get from 1 to 4? I times by 4. 4 to 16, I times by 4 again. 16 to 64, I've times by 4 again. So a geometric sequence is where you're multiplying by something to get from one term to the next. So let's apply this to our sequence that we've been given. Now, yes, it's got surds in it. Yes, it's not the easiest of sequences, but if we're not confident with surds, let's see how we can get a little bit creative. So I know to get from the first term to the second term, I'm going to be needing to multiply by something. I don't know what that is yet, so I can just call it n. What do I do to get from that term to the next term? I multiply by n again. Okay, so each time I'm multiplying by something to get to the next term. Now you could just think to yourself, okay, what do I multiply root 5 by in order to get to 10? Or you could think to yourself, what do I multiply 10 by to get to 20 root 5? And if you're confident with surds, absolutely use that root. If you're not super confident, then what we could do is look at the integers, so just the whole numbers. So I know that my second term is 10 and my fourth term is 200. So how do I get from 10 to, 200? Well, I'd have to multiply by n and then multiply it by n again. So I could form a little equation for myself. I know that 10 times by n equals 200. So what I can do is simplify that for myself. So I'd be left with 10n squared equals 200. What could I do to solve that equation? Divide both sides by 10. So I'd be left with n squared equals 20. And then what would I do? I would square root both sides. So therefore n must be the square root of 20. So the common difference is root 20. So once I know that, I am asked to work out the next term of the sequence. Well, the final term is 400 root 5. So I'm going to need to multiply that by root 20 because that's my common difference each time. I'm timesing by root 20. Okay, so let's try and split that up. That's the same as saying 400 times by root 5 times by root 20. Let's bring the surd together. So that would give me 5 times 20 is 100. Remember, when you're multiplying surds, you just bring them together under 1. What is the square root of 100? It's 10. So therefore, the next term must be 4,000. So this is a slightly trickier question because it's got surds, but just do what you know. Just try and think creatively. Geometric means multiplying each time. So just form an equation for yourself. Okay, so the next part of the question, I'm told that the fourth term of a different geometric sequence is 5 root 2 over 4. So I've got my first term, second, third, fourth, fifth, and sixth. I know the fourth term is 5 root 2 over 4, and that the sixth term is 5 root 2 over 8. So once again, I need to think to myself, what have I multiplied this by? and then multiplied this by again in order to get to the 6th term. So 5 root 2 over 4 times by n squared gives me 5 root 2 over 8. This is a little bit more complicated, but in order to isolate my variable, in order to isolate n squared, I can divide both sides of the equation by this term here. So I'd be left with, let's get rid of this working here, n squared equals 5 root 2 over 8 divided by 5 root 2 over 4. Now, what do we do when we divide fractions? So we keep the first one as it is, we change the sign to a multiplication, and we flip the fraction over. So it'd be 4 over 5 root 2. So n squared would be, remember when you're multiplying surds, what does this mean? That means 5 times root 2 times by 4. So just multiply the numbers, that would be 20 root 2. And then the same for the next part, 8 times root 2 times by 5. So 8 times 5 is 40, and you're left with root 2. So what is this fraction simplified? So remember, when you have a fraction and everything is being multiplied on the numerator and the denominator, any terms that are the same cancel out. So root 2 over root 2 is going to cancel out. So n squared is 20 over 40, which we could simplify to 2 over 4, which we could simplify to a half. So you know that n squared is a half. And what's the final part? We're going to have to square root both sides. So n would be the square root of 1 over 2, which would just be 1 over root 2. So I know that what I'm multiplying to get from one term to the next is 1 over root 2. So let's just write that up here. And what's the question asking me to do? So it's saying, given that the terms of the sequence are all positive, work out the first term of the sequence. Okay, so we know that we've got the 4th term, which is this. How would I get to the 3rd term? So let's just quickly demonstrate. So to get from the 3rd term to the 4th term, I'm timesing by 1 over root 2. So to work my way backwards and to get from the 4th term to the 3rd term, I'm going to have to divide by 1 root 2. Now, just to make life easier for yourself, when you're dividing by a fraction, what are you doing? It's the same as multiplying by its reciprocal. So essentially, it's the same as multiplying by root 2 over 1, which is just root 2. So to make your life easier, hopefully you simplify the fraction. So to get from the 4th term to the 3rd term, I'm going to multiply by root 2. So the 3rd term is going to be 5 times by 4 over 4. Once again, if this is confusing you, then just to recap on why. So 5 root 2 is the same as 5 times root 2, and I'm multiplying that by root 2 over 4. What's root 2 times by root 2? That would simplify to the square root of 4 over 4. And I've spotted a little mistake I made. So that would be 5 times 2 over 4, not 4. Okay. I meant to say 5 times root 4. So what's that? 5 times 2 is 10 over 4. So I know that the 3rd term is 10 over 4. I then need to get to the 2nd term. And what am I going to have to do? Well, I'm going to have to work backwards. So once again, I'm going to multiply by root 2. So 10 over 4 times by root 2 is going to give me 10 root 2 over 4. So the 2nd term is 10 root 2 over 4. And what's left to get to the 1st term? I'm going to have to multiply by root 2 again. So let's do that. I've got 10 root 2 over 4 times by root 2 over 1. So 10 times by root 2 times by root 2 over 4. And root 2 times by root 2 would simplify to root 4. And root 4, the square root of 4 is just 2. So I'd be left with 10 times 2 over 4, which is 20 over 4, which is 5. Okay, so we've made it to the last question. So we're told that here is a solid sphere and a solid cone. We're given very kindly, the formula for the volume of a sphere and the formula for the volume of a cone. All measurements are in centimetres, and I'm told that the volume of the sphere is equal to the volume of the cone. Well, that's super nice that they've told me that, because I can then make this equal to this, because I know they are equal. So I can just say 4/3 times by pi times by r cubed equals 1/3 times by pi times by r squared times by the height. I've just separated them with multiplication just so you can see what I'm doing in a slightly easier manner. You don't need to do that, obviously. So I know that they are equal, so I made them equal, and I can just rearrange them to simplify them as much as I can. So now, there are so many ways to do this, so it really depends on what way works best for you, what way of simplifying works best for you. Something you could do just to make things a bit easier is maybe write everything as a fraction. So you could write 4 pi r cubed over 3. Essentially, you're just multiplying these fractions. Yeah, so remember, anything over 1, like to write anything as a fraction, you just write it as over 1. So that would give me pi r squared h over 3. Okay, so I've just simplified it a little bit. Then what I can do is multiply both sides by 3 to get rid of my denominator at the bottom. So that means I'm multiplying this by 3 over 1. That would give me 12 pi r cubed over 3 is equivalent to pi r squared h. What could I then do? I could multiply both sides by 3. So I know, well, it depends. Or you could have just divided, which would be easier. I think let's just divide, actually. So let's just simplify this fraction. So 12 divided by 3 leaves me with 4 pi r cubed equals pi r squared h. What can I then do? Well, I'm looking to divide anything just to simplify it as much as I possibly can. So let's divide both sides by pi, because then that eliminates that variable. I'm left with 4r cubed equals r squared h. What else is a common variable that I could eliminate? Well, I could divide both sides by r squared. So I'd be left with 4r equals h. Okay, do you see how I've eliminated every variable to just be left with r and h, which is what I'm trying to find? So, and this is another common ratio kind of question that people always seem to get confused by, so hopefully let's go through it in a way that makes sense. I know that 4r equals h, okay, and I need to write the ratio of r to h. So let's think about what's actually happening. 4 lots of r is equivalent to 1 lot of h. So if you think about it, h is 4 times larger than r. So if h is 4 times larger, if r was 1, h would be 4. So it's kind of like the inverse of what some people might automatically think. They think, oh, 4r is h, so therefore the ratio would be 4 to 1. But it's actually the opposite, because h is 4 times larger. Okay, 4 lots of r make 1 lot of h. So the ratio of r to h is going to be 1 to 4. Okay, so in this part of the question, we are told that we've been given a different solid sphere and a different solid cone. So that means don't use any of the information from the last question, just focus on this part. I've been given the formula once again for the surface area of a sphere and the curved, this is very important, just the curved area of a cone. So just think to yourself, how do you work out the surface area of a cone? Well, the curved surface, so imagine an ice cream cone, the curved surface area would be like the ice cream cone bit, but if it's a solid, that means that the cone is closed. So imagine an extra little bit of a wafer in the shape of a circle closing that cone. So the curved surface area is the ice cream cone bit. But then to close the solid, you also have this, which is just a circle. So a bit cheeky because I haven't told you the whole thing. But what they have done is they've told you the surface area of the sphere is equal to the total surface area of the cone. Now, if they have underlined or worked in bold, it means it's important. Okay, so that's a really important word to hopefully hint to you that you need the total surface area. So the total surface area of a cone is pi RL, which is the curved surface area, plus the area of the circle. And the area of a circle is pi r squared. Okay, so once again, we've got the information we need. We know that 4 pi r squared, which is the surface area of the sphere, must be equal to the total surface area of the cone, which is this. You might have already known that, you might have memorized the formula, that's fine. If not, just think to yourself logically, what's the total surface area? It's going to be something that you're able to figure out. So pi RL plus pi r squared. Once again, I'm being asked to find the ratio of r to h. So let's see what we can do here. Okay, so what I could do, because I've got two terms here, there's a few things I could do. You could factorize or you can subtract the terms. I know that 4 pi r squared and 1 lot of pi r squared are like terms. Therefore, I can just subtract pi r squared from both sides. So I'd be left with 3 pi r squared equals pi rl. So you've simplified your equation. So what else can we do to simplify it even further? Well, you could divide by pi. So you'd be left with 3r squared equals RL. And then what could you divide by again? You could divide by R. So you know that 3R equals L. Okay, so you might think that's the end of the question, but it's not. So this is a really important little thing that we found out. I know that 3R is equivalent to L. So let's write that here. Now, hopefully you know that H is the height of the cone. Okay, so that's going to be the perpendicular height. So H is the perpendicular height, and I need to find the ratio of R to H. So what could I do? I know that 3R is equivalent to L. So what I could do, I could draw this little right angled triangle, because I know this is perpendicular, because the height of a cone is always perpendicular to the radius. So I could substitute, instead of saying L, I could write 3R, because then the radius is R and the hypotenuse is going to be 3R, or the slant height is 3R. So I can form myself a nice Pythagoras triangle. And all I'm dealing with is R and H, because that is what has been given to me. That's what I want to work out. So let's see what I can do. Well, using Pythagoras' theorem, I know that a squared plus b squared equals c squared. I know that 3r is the hypotenuse, so therefore I'm going to rearrange it to this. Okay, obviously A and B, it doesn't matter which one's which, they're just the two shorter sides. So c squared is going to be 3r squared. Take r squared must equal h squared. This is another little bit that people might get caught out on. 3r squared, what does that mean? It means 3r times by 3r. So if you ever get a little bit confused, just write out what it actually means, just to remind you, because a lot of people might expand that as 3r squared. But it would actually be 9r squared, because 3 times 3 is 9, r times r is r squared. Okay, so you've got 9r squared, take away r squared equals h squared. Then what could you do? Well, you could simplify it. So that would give you 8r squared equals h squared. And you are trying to write it in the ratio r to h. So what you could do is, because they want it in square root form, you could square root both sides. So if you square root everything on both sides, you'd be left with the square root of 8r equals h. Okay, you've square rooted everything on both sides. So let's move this over here. I know that the square root of 8 times by r is equivalent to h. And I need to write the ratio r to h. So once again, think about what we did with the last question where we effectively flipped the ratio. So some people might think, okay, that ratio is going to be square root of 8 to 1, but it's actually going to be flipped. So the ratio would be 1 to the square root of 8. And rewatch the last video if you don't understand why. And that is how I would do that question.